Yeah, welcome to the Hungarian audience from my side, from Germany. Unfortunately, I cannot be with you directly, but I'm trying to give you an idea about the subject which I was asked to introduce, which is global warming and challenges for the future for the wine industry. And as you can see from these images, I picked images from the Eastern European, the Balkan countries, because I want to focus a little bit on the subject area right now. Where do I come from? Not everybody knows Geiseinheim. Geiseinheim University, maybe you know better the variety Riesling, or Johannisberg Riesling, as it's called in a couple of places. And the reason it's called that way is because Chateau Johannisberg lends his name to the Riesling variety, and Chateau Johannisberg is located in Geiseinheim. That is one thing. The other thing which qualifies this place to talk about global warming is that the 50-degree latitude north is running right through the vineyard of Chateau Johannisberg, and that used to be, in the former times, called the northern limit of viticulture. And of course, we know that has changed quite a bit. It's a small place, the university, focused on wine, beverage, technology, horticulture, and so forth, with about 1,800 students. Coming back to the subject, give you a little bit of an outline. I'll talk about the CO2 factor, not only about that CO2 is warming, but also what kind of effect CO2 can have. Some observations and facts on examples from Central and Eastern Europe. Water, because that's a big issue in a lot of areas around the globe. Soils, because soil is a very much underrated climatic factor. And of course, all grape growing is based on a soil. Plant protection, where do we go? What do we need to do? Which production systems are you actually capable of using in the future? And other consequences in the discussion on climate change. Now, I'm going to start with a simulation. I'm showing you something. What you can see here, this is basically the Earth, the planet. And in the middle, we have the equator. And this is the northern hemisphere, and this is the southern hemisphere. And what you can see here, and as I can show you to much more detail, this block here is delimiting the areas on the northern hemisphere where you grow grapes. We do have viticulture. It's roughly between the 40th and the 55th degree latitude today. And this here is the southern hemisphere, where you grow grapes between the 30th and about the 42nd degree latitude. And this here is the CO2 concentration, and it has evolved over centuries now. And what you can see, CO2 concentration is rising. Here is the clock running. So that would be what was the CO2 concentration in 1998. So it's increasing constantly. But what you also see is that in this side, on the northern hemisphere, you have these large ups and downs. And that is because the northern hemisphere has a lot more land mass, a lot more plants, and plants absorb CO2 in the summer and release CO2 during the winter. And that's why you have these huge fluctuations. And the fluctuations are largest right there where we grow grapes, basically, or further to the north. But plants do not only take up CO2, they also release water. So this up and down is also speeding up the hydrological cycle. And this is causing more weather extremes on the northern hemisphere than in the southern hemisphere, where everything is relatively stable. So looking at the effects of this increased CO2 and the increased temperature, which is related to that, which I'm going to show you in a moment, we can see that the distribution of grape growing across the planet, so that would be the black areas, this is where grapes are grown in the northern hemisphere, and this is where grapes are grown in the southern hemisphere. This is from a study I did a couple of years ago with a colleague of mine from the United States, Greg Jones, and then simulating what might happen to the temperature in the vegetation period, in the growing season. That is for the northern hemisphere between April and October, and the minimum is about 12 degrees, and the maximum is about 22 degrees. And how would that evolve in the future? And you can see, if you simulate this for the year 2100, then of course we are moving northwards. Or if you do the same for the southern hemisphere, of course we move southwards. And of course we have today grapes grown in England, grapes grown in Sweden and Norway, up to about the 55th degree latitude. But what is actually the observation, or what are the observations? What kind of facts do we have? So I choose the eastern part, the part around the Danube river, because that's very much an example of Hungarian conditions. And for Hungary, as an example, I use long-term data for pH, because a long time ago, I had a research project together with colleagues from Hungary, and we worked in vineyards in pH. So what do we observe? And as a reference, I show you the conditions in Geiseinheim, so where I come from, what has happened over the last approximately 100 years with the temperature, the average temperature between April and October, or October and April in the southern hemisphere. And you can see down here we have Oxford. Now, Oxford is not known for growing grapes as much, but as you can see, the conditions of Oxford now are relatively equal to the conditions we had in the 80s and the 90s of the last century in Germany. If you look at pH, you can see a similar thing, a similar pattern with a strong increase in temperature approximately since 1980. I'm coming back to this decrease in a moment. And then you have Croatia, you have Vienna, you have Belgrade, and they all have very similar patterns, a strong increase since about 1980, but a substantial decrease after the Second World War. The reasons I come back in a moment. Prague, they're all basically Bulgaria, the grape growing areas, Romania, they all show the very similar trends, and Slovakia as well on a much cooler basis. All have increased, all are continuing to increase. And just to give you an idea, as a reference, I put in Bordeaux from France, and now the temperature in pH is approximately now what used to be the temperature in Bordeaux during the 90s of the last century. And this warming period is called the global brightening period, which means brightening because actually beginning in the 1980s, we had humans have started to clean up the atmosphere because we introduced environmental filters to manufactories, aerosol were reduced, and so we cleaned up the atmosphere, a side effect of global climate change. And this decrease here probably, which was much, much stronger in the eastern part of Europe than in the western part of Europe, is probably due to pollution. So actually, at first it decreased since the Second World War, and then it increased again. And just to give you a reference, the warmest ever year on record we have had was 2018. And 2018 here in Germany, we were usually down here, we were up to where pH is approximately today. Now, of course, this has consequences for grape variety choice. And just to give you an idea, this is the distribution where grape varieties are grown according to temperature up here. And in our place, if you just take the average temperature at the beginning of the last century, so between 1885 to about 1925, we were there. Then up to the year 2000, we were approximately in this area. And just to give you an idea about 2018, which actually reflected the prediction for this place made for the year 2050, we were about here. So this is about the same average, as I said, value for pH, which does not mean that you cannot grow Chardonnay anymore, or you cannot grow Pinot Noir anymore, or Riesling, or so forth. The problem is with this view that we only know the minimum. So we know this, but we do not know the maximum. So therefore, we cannot say if it gets that and that warm, we cannot grow any more Chardonnay in this place. We need to do a lot more research in this. Coming to a next issue, water, which is a really big one. This is a simulation based on modeling effort of a Portuguese group, and there we're looking at the distribution of water stress across Europe. If you have blue areas, there's no water stress, and it goes a little bit towards the yellow, red areas, there's more water stress. And this is a condition of the past. And I highlighted Hungary here. And you can see that on average, there is a medium level of water stress, which was experienced in Hungary in the past. On the right, we have the future, the simulation of the future. And if you look at Hungary in this place, then you can clearly see that it's much more yellow and red. So water deficit is probably going to become an issue more than it has already been in the past. And looking at trends, summer rainfall trends, for instance, I choose again this map and was looking at some summer rainfall, how it is distributed for some of the area in the eastern part of Europe. And it's a hydrological summer, which means that's the sum between May and October. And here we have pitch, and you can see over the last 100 years, at first, there was actually a decrease in about 1980, and then it seems to be that we actually have an increase in summer precipitation. But nevertheless, you have higher temperatures and higher evaporation, higher use of water. Looking at winter rainfall trends, and you can see actually a clear trend that, that the winter rainfall seems to have diminished continuously since about close to the 1900s, so for an area like Pécs in Hungary. So the restoration of water in the soils maybe actually become problematic in the future. So which raises the question for grape growing, we need to address the rootstock question again. I'm not going to talk about it, I don't have time for this, but this is an area we need to address. So looking at the soils, which is a very much underrated climatic factor. Now soils are the key to sustainability. It's our most valuable resource. And soils can store massive amounts of carbon, between 1,500 to 2,500 billion tons of carbon are stored. This is more than in the atmosphere and more than in all plants on Earth. It takes a long time to build soil, and every year we lose about 24 billion tons of soil due to erosion. And after the Paris Climate Summit, there was an initiative launched with saying, if we could increase the carbon content in the soil by 0.4% per year, we could balance out the global greenhouse gas emissions. And that's what they call the cut per mil initiative. And I just wanted to show you how soil management can actually affect carbon storage in the soil. That which means here SOC stands for soil organic carbon. And what you see up here, this is just a simulation over the last 13 years with a model and different treatments, meaning in this green area, you have like a cover crop all year round, which of course takes up carbon, and you're left where you leave the prunings out in the vineyard, and the leaves drop, they stay also out in the vineyard. And then you can see the simulation over this time period, you can store about 0.7 tons of carbon per hectare in a year. You see the dotted line here. This is actually also soils are warming up. And if you take that into account, that the soil has already been warming up as compared to 30 years ago, it will cause an effect to have less carbon stored in the soil because higher temperature cause higher CO2 losses. Down here, you only have a cover crop in the vineyard from October to March, and the rest is open soil management. Other than that, you have the same treatment as up there, and you can see you have carbon losses. It's going to decrease. And that's a huge management question. And of course, you cannot have carbon cover crops in all places because there's water competition, and that makes a solution very, very difficult. And also, if warming is considered here, the losses are even more. Plant protection, where to go? Now, the conditions are set by the European Green Deal. We need to reduce chemical plant protection products by 50% until 2030, which is a huge, huge challenge. And I cannot go into detail, but we have old problems on pests and diseases, which are becoming more difficult. We have new diseases showing up. We have wood diseases, which are spreading out massively and very fast. We have new insect types, there are Pierce's disease and other vectors, where there are certainly more surprises ahead. And not everywhere in Europe, but for us, 2016 and 2021 was an absolutely downy mildew disaster. We had lots of problems. And if you want to work organic, this is absolutely challenging under our condition. And at least part of the solution need to be disease-tolerant varieties, because other than that, you cannot actually achieve the goal of 50% reduction of plant protection agents. So which production system for the future? Now, this is a record of a vineyard since 1932. The red line is the alcohol content, the potential alcohol content, and the black line is acidity. And you can see how this has changed specifically since the beginning of the 80s for the last 40 years. Acidity has dropped massively and the potential alcohol has increased, so the sugar potential has increased. So we need to find ways to slow down maturity, to actually move maturity back into time, back into cooler months. I'm not going to have the time to talk about what we can actually achieve and why. Other issues for the wine industry, packaging. You know, if you talk about marketing, packaging is a big issue. Do we need to change away from glass? More than 50% of the carbon footprint of wine production is glass. So just a 15% reduction in weight could save about 6.5 million tons of CO2. And a reduction of 30% would result in 2 to 10% reduction of all impacts associated with a bottle of wine. Now, and if we move to cardboard to bag-in-box, yeah, you can actually have a 80% impact reduction. But will the consumer accept that? That's another question. So we need to work on all of these little details, in fact, to become a larger picture. To put all those results back together, climatic developments are very region-specific in the Danube area. I showed you pH as compared to other regions of the world. Water will be one of the dominant issues in the future. Yeah, in some places, both too much, sometimes can come too much flooding and so forth. How do we control greenhouse gas emissions? Soil can be a source of greenhouse gas emissions, but it should be actually sequestering greenhouse gases. We need disease-tolerant varieties. Are the consumer accepting them? Can we actually change the whole direction viticulture is producing wine? We need, of course, new technology. I'm listing some here. I didn't have the time to talk about this. Soft pruning, new minimal pruning, delay ripening, cultural practices are constantly adapting so we can actually meet the risk we are facing with climate change. And you can also look at it a little bit differently. 1 hectare of vineyard produces 10 million liters of oxygen. If you don't look at the CO2, and that's enough for 20 people, we have about 7.6 million hectares in the world. And so vineyards are producing about enough oxygen for 121 million people. Thanks for the opportunity to present. Sorry that I could not be there in person. Thank you for your attention, and let's save the earth. It's probably the only planet with wine. Thank you.